right, hello grade 12s. In this lesson, in this video, I'm going to go over some of the basic skills review. Main focus in this video is going to be the MHF4U prerequisite skills pages, okay, because that is what our quiz is going to be, or the foundation of our quiz is going to be on, okay. So just looking at the basic skills here, okay, in this first question, you're really looking at distributing through the brackets and collecting your like terms, okay? That's the main thing with this topic here. So I'm going to do D and I'm going to do J just for you to see here. So if I'm doing D, I'm just going to kind of do it right over here. I'm going to distribute this -7 into my bracket, and I'm going to distribute this -4 into my bracket. Please remember the negative in front of that 4 is super important, as well as the negative in front of that 7. So when I distribute that in, I get -14h squared minus 7 times 5 is 35 minus 35h. -4 times 5, that's going to be -20h squared, and -4 times -3 is +12. That's going to be h. Now, it does say simplify, so when we're simplifying, we are also collecting our like terms. Okay, so those are two like terms here. Here are my other two like terms. I am going to combine those together. I have -14 minus 20, that is -34h squared, and I have -35 plus 12, that is -23h. Now there's a possibility that I make some arithmetic mistakes here, but I am going to do my very best to not make any mistakes as we go. The next one, I'll do J, okay? In this one, you're just practicing your, foiling, okay? So foiling here, I have two terms in the first bracket, two terms in the second bracket. So to expand and simplify here, I need to multiply each term in the first bracket by each term in the second bracket. Okay, when I do that, I get 20x squared plus 5xy. Then I'm going to take my other term, my -7y, and I'm going to multiply that by both terms in this bracket. When I do that, I get -28xy and -7y squared. Okay. Now again, I'm going to collect my like terms. In this case, only our middle two terms are like terms. And so when I collect those or get those two together, we get my 20x squared stays the same. 5xy minus 28xy is -23xy. And my -7y squared just stays the same. That is your final answer there, okay? Now for these questions, just a reminder that the answers are right here. 20x squared minus 23x minus 7y squared. So that one looks pretty good. In the next one, you are doing a variety of factoring skills here, okay? In the first one, you're doing lots of common factoring. I'm going to do D here. If I want to factor D, what D is going to look like is I'm going to factor out a 3. I can factor out 2 m's, and I can factor out 3 n's. Okay, they have that in common. When I do that, in the first one, I'm left with n, or actually, oh, that's crazy. No, 3m squared n cubed. I'm factoring basically that whole thing out. I'm just left with 1. And in the second one, I'm left with -3 m n. There we go. That is factored form. I'm just common factoring out the things that they have in common, and we get our factored form, okay? You have also a couple different types of factoring. So you have a simple trinomial where you're just looking for two numbers that multiply to -28 and add to -3. So in this one, I'm thinking about two numbers that multiply to -28 and add to 3. So I'm thinking like 7 and -4. Okay, when I do 7 minus 4, that does equal 3. That's perfect. So that's going to be x plus 7 and x minus 4. Okay, that's what that factored form looks like. K is a difference of squares. Square root. That's equal to m plus 3, m minus 3. Okay, so again, just recapping, this is basically a grade 10 review, this section here. Okay, and then you have this one here where you have the 12 out front. This is a complex trinomial. So in this complex trinomial, what we're going to do is I'm going to use decomposition. This is my preferred method, and if you have a different preferred method, you can use whichever method you want. So typically what I do here is I take that 12, I multiply it by the -1. So I'm looking for two numbers that multiply to -12 and add to our middle term, which is just +1. That's going to be 4 and -3. So what I do here is I break my middle term up. Okay, so that's going to be 12x squared plus 4x minus 3x minus 1. I'm going to common factor my first two terms, and I'm going to common factor my second two terms. So in the first two terms, I'm going to factor out a 4x. That leaves me with 3x plus 1. In the second two, I'm going to factor out just a -1. That leaves me 3x plus 1. Noticing here that these two brackets are the exact same. Now I have my two final answers here. This is going to be 3x plus 1 and 4x minus 1. Okay, so I factored that using decomposition. Again, it doesn't matter which factoring method you use, but you do need to know how to factor in this course. It's extremely important, okay? Evaluating these, you can mostly plug into your calculator. Two things I'm going to point out here. 5 to the power of 0, anything to the power of 0 is always equal to 1, okay? The other thing that I'm going to point out here is that if you have a negative exponent, you flip that to make the exponent positive, and then I end up just with 1/9, okay? In these questions, I don't want decimals, I do want fractions, okay? We say fractions are exact values, okay? So if you're answering these questions, I would like to see these in fraction form, okay? And I think if you look here, all your answers are in fraction form, okay? And the last one, you're solving, okay? So you're using a variety of strategies to solve for the variables in those equations, okay? Here, sorry, I skipped one. Simplify here. So we're multiplying here. X squared times x to the 3. When you're multiplying, you add the exponents. So this is going to be x to the power of 2 minus 3 because this is a negative. Or I could say plus -3. And that's going to be y to the power of 4 plus 2. That simplifies to x to the power of -1, y to the power of 6, which simplifies even further to y to the power of 6 over x. Okay, because of that negative exponent there, we can put that x into the denominator. These solving ones here, again, there's a variety here. I'm going to do something like, how much time, what am I at here? I'm at 8 minutes, okay. I'm going to do something like C and something like F. Okay, maybe I'll do 3 and E. So if I do C here, okay, we have 4 minus m over 3 equals 5 plus m over 2. Basically what I want to do in this one is I want to get common denominators everywhere, okay? My common denominator here is going to be 6. So I'm going to get a common denominator of 6 everywhere. So that means I'm going to multiply this by, 6 is, I'm going to multiply top and bottom here by 6. So that's going to be 24 over 6. I'm going to multiply the second fraction by 2. That's going to be 2m over 6. I'm going to multiply this one by 6. That's going to be 30 over 6. And I'm going to multiply this one by 3. That's going to be plus 3m over 6. Once you have that, you can actually cancel out all of your denominators, and this just becomes a simple linear solving. So what I'm going to do here is I have 24 minus 2m plus 3m. Oh, shoot. Equals 30 plus 3m. Okay, I'm going to collect my like terms here. I'm going to bring my 2m over to this side, and I'm going to bring my 30 over to this side. And when I do that, I get 24 minus 30 equals 3m plus 2m. And we get, that's negative 6 equals 5m. I'm going to divide both sides by 5. And we get that m is equal to negative 6 over 5. Let's check that answer for C. That looks pretty good. Negative 6 over 5. Okay. For E, this is in factored form. When you're solving quadratic or something in factored form, and it's already set equal to 0, basically what you're doing there is you're just saying, well, when does each bracket equal 0? So in this case, you're just going to go, when is 2x plus 5 equal to 0? And when is 3x minus 1 equal to 0? Again, just I can isolate for that x, bring the 5 over, and then divide by 2. So we get x equals negative 5 over 2. Again, I'm going through this just a little quick. I can answer any questions that you have for me. But like I said, most of this is like grade 10 review, okay? If you're not sure how to do this, I'd recommend coming in at lunch. Email me, I can send you some videos. But this is mostly grade 10 review and stuff that you would have gone over in functions or been covering in functions. Okay, so I am going a little fast through this, especially this first part here. Okay, in this one you get x equals 1 over 3 when you isolate for x. Okay, and f you just need to factor. Okay. All right, I'm gonna go over this part. All right. And I'll try to do every question. Again, I'm going to go fast just because I want you to be able to, I'll talk through it, but I'm going to go fast just so I can get most of this done and then you can have some time to work this period. Okay. What we're doing here is we are doing, we're subbing in. It's giving me two functions. It's giving me f of x is equal to something and g of x is equal to something. This is kind of like what I did in lesson 1, or what we do in lesson 1. So basically here, I'm just going to sub in my negative 3 for x. So I'm going to get, that's going to be 2 minus 3 bracket negative 3. That's going to be equal to 2 plus 9, which is equal to 11. Okay. F of 0, I'm just subbing in 0. That's equal to 2 because negative 3 times 0 is 0. C is a little bit trickier. Okay. C says negative 2 times g of 3. So what I'm going to do here is I'm going to write negative 2, and then I'm going to substitute in 3 into the g function. So that's going to be 2 bracket 3 squared plus 5 bracket 3 minus 1. I'm going to simplify the brackets first because of BEDMAS. I get negative 2. That is 9 times 2 is 18. Plus 15 minus 1. Okay. That is equal to negative 2 times 32. And negative 2 times 32 is negative 64. Again, I don't have my answers in front of me, so there could be arithmetic error, but I think we're okay there. Okay, with the next one, we're subbing in a half. Again, I did mention earlier that I do like to work in fractions and keep my answers in fractions. Okay, I do accept decimals, but like I said, I do prefer fractions. So when I do this, that is going to be times 2. That's going to be equal to 1/2 plus 5 over 2 minus 1. And if I simplify that, I get 6 over 2 minus 1, which is equal to 4 over 2, which is equal to 2. I think... Yep, I think that one's correct. And with this last one, we're doing 3x. We're subbing in 3x into f of x. Oh, this one's interesting. We get 2 minus 3 bracket. We're subbing in 3x. When I do that, I'm going to multiply into the bracket. I get 2 minus 9x. I can't simplify that anymore. Those are not like terms. So we are done at that point. Okay, state the slope and y-intercept for each. Okay. This would be grade 9 stuff here. Okay, so y equals mx plus b. So it may be a little bit since you've done this stuff, but I'm giving you kind of a recap here. So y equals mx plus b is your slope y-intercept. This is our slope. This is our y-intercept. So as long as you have y isolated, you can determine your slope and your y-intercept. Now in this case, in the first one, my slope is going to be -4. It's the term in front of the x, meaning that my y-intercept is 2. Okay, that one's pretty straightforward. In the next one, notice that y is not isolated for, so we are going to need to isolate for y. Okay, so in order to isolate for y, I'm going to bring my -6x and my -7 to the other side. I get 2y equals 6x plus 7. I still need to isolate for y because I got to get rid of that 2. I'm going to divide everything by 2. When I do that, I get y equals 3x plus 7 over 2 or 4.5. Either works here. So in this case, my slope is 3 and my y-intercept is 7 over 2. Okay. In the next one, same idea here. We are going to isolate for our y variable. Okay. You can do this in a variety of ways. You can distribute the 2 into the bracket if you would like. Or you can divide both sides by 2. There's totally your preference on the way you go about doing this one. Whoa. I lost you there. All right, here we go. And what I'm going to do here is I'm going to distribute that. So I get 8y minus 6 equals 9x. Now I still want to isolate for y. I'm going to bring that 6 over where it's going to become a plus 6. So I get 8y equals 9x plus 6. And then we are going to divide both sides by 8. Everything by 8. And when I do that, I get y equals 9/8 x plus 6. So my slope is 9/8 and my y-intercept is 6. Okay? All right. Continuing on. This says, determine the equation of a line given the following information. So in this course, you're actually going to see a lot of questions like this, where I'm asking you to determine the equation of a function. Could be a rational function, could be a polynomial function, could be any type of function that we're looking at in this course. I could say, give me the equation or determine the equation of said function given this information. Okay, that's a common question in this course. So what I'm doing in this question is I'm kind of giving you, based on your foundation, your knowledge that you have already, can you do this skill? And then we're going to apply this skill to other functions in this course, okay? So the first one here, first of all, it's really important to remember that y equals mx plus b is our equation of a line, okay? So the first one here, I tell you that the slope is 4 and the y-intercept is 2. Well, this one's pretty straightforward. It's just going to be y equals, my slope is 4, x, and my y-intercept is 2. So just 4x plus 2. That is the equation of a line with a slope of 4 and a y-intercept of 2. Now in the next one, it's to get a little trickier. It doesn't tell us the y-intercept. So we do not know what b is equal to in this case, which is my y-intercept. We don't know what that is. So I need to find that, okay? But we do know our slope, and we do know an x and a y. So what I'm going to do is I like to write out y equals mx plus b, and then I like to put in what I know. Well, I know y is -5, I know my slope is -3, and I know my x is 1, based on the information given. I just need to figure out now what b is. So I'm going to solve for b. I get -5 equals -3 plus b. I'm going to bring that 3 over here, and I get -5 plus 2. Oh my gosh, I'm just rushing here. Plus 3 equals b. I get -2 equals b. So if I want to write the equation of that line, the equation of that line becomes y equals, my slope is -3, x minus 2. Okay, with my y-intercept. All right, next one. Okay, the next one takes a little bit more intuition. Okay, a little bit more kind of basic knowledge and kind of thinking outside of the box a little bit. So this one tells us an x-intercept. It tells us our y-intercept. So we know a couple things. Whoops. My y-intercept, this is my b value. Okay, so I'm going to write out y equals mx plus b. Now I'm going to put in what I know. I know b is -5. It tells me my x-intercept is 2. What information is that exactly? Okay, that tells me when a graph crosses the x-axis. Okay, and so that tells me that I have a point on this graph that is 2, 0. Okay, it's on my x-axis at 2. Let's see, I don't know why this isn't working. There we go. It's a point that's right about here. And the coordinate of that point is 2, 0. So you got to know or recognize that an x-intercept is the point 2, 0. And so I'm going to use that x and that y coordinate and put that into my equation. So I have y equals 0 equals m we don't know, and I know that x is 2, and I have the -5. So what I'm going to do here is I'm going to solve for m. So I'm going to go 0 equals 2m minus 5. I'm going to bring my 5 over to this side, where it becomes 5 equals 2m. I divide both sides by 2, and I get that m is equal to 5 over 2. So my equation for this one becomes y equals 5 halves x minus 5. Okay, there's our equation for that. Name the type of function given the table of values. How do you determine your decision? So last year, you would have done something called finite. Actually, I'm going to write this in a different spot. Last year, you would have done what's called finite differences. Okay, and this is where you take the difference between your y values. Okay, so you start with your what's called our first differences. Okay, and to determine your first differences, you subtract your y values, and you start from the bottom and you go, well, what's 15 minus 1? That's 14. What's 1 minus -1? That's 2. What is -1 minus -3? That's also 2. What is -3 minus -17? That's 14. So I'm subtracting those values, okay? And I'll just write here so for you to see, 15 minus 1, right? That's how I'm getting those values. You're subtracting. If your first differences are the same, so I'm going to write that down here. If your first differences are equal, you have what's called a linear function. Okay, now in this case, our first differences were not equal. So if that's the case, we do our second differences. So we're going to do our second differences. And in this case, I'm just going to do the exact same thing. I'm going to do 14 minus 2. 14 minus 2 is 12. I'm going to go 2 minus 2. 2 minus 2 is 0. And I'm going to go 14, or 2 minus 14, and 2 minus 14 is -12. Okay, in this case, if my second differences are equal, you have what's called a quadratic function. Okay, or a function that's like y equals x squared. Linear function is like y equals x to the power of 1. Notice how the exponent here matches first differences, second differences, right? Okay, so last year what you would have done, and I put this question on here just so I could talk about this specific idea. Last year you would have stopped there. You would have said, well, our first differences aren't the same, our second differences aren't the same, so this is neither a linear or a quadratic function, okay? If that happens this year, we're going to go further than that. We're actually going to look at higher degree functions. And so in this case, we are going to determine what the third differences are. And when I do this, 12 minus 0 is 12, and 0 minus negative 12 is 12. In this case, our third differences are equal. And if your third differences are equal, you have what's called a cubic function. And a cubic function is something like y equals x to the power of 3. Again, noticing that my exponent matches my third differences, okay? So that one there, if you wrote neither, or you did that and wrote neither, perfectly acceptable, okay? Totally fine. But we are going to get into higher degree, we call it degree functions in this course, okay? Okay, we still got a little bit to go. Where are we at? 26 minutes. All right. State the domain and range of each function. So I'm going to talk about this a little bit more on Monday, but I'm going to show you or kind of recap how we do this. Now, it's really important here that you remember kind of your A, K, C, and D values. A being vertical stretch or compression, K being, actually, no, sorry. I'm going to take this a step back here. Oh, no, we're good. Sorry. Horizontal, stretch, or compression. C being vertical shift, and D being horizontal shift. Okay? And then knowing also what the basic function looks like. So we have our first function here, which is y equals 2x minus 1. This is a linear function that looks roughly like that. The domain of this function is just x as an element of all real numbers. Okay? That goes forever to the left and to the right. Our range of this function is y as an element of all real numbers. Okay, there are no restrictions on this function. All right, in our next one, B, this is a parabola. Okay, it's a quadratic because of the square value there. Okay, so what does this one look like? This one looks something like this. A couple things we're going to point out here. It's in vertex form, so my vertex is at 4, 1. That's going to be roughly right here. And this tells me that it's flipped like that. So that's roughly what this graph looks like. If I want the domain and range here, the domain of this function is x as an element of all real numbers. This function goes forever and ever to the left, forever and ever to the right. Okay, there is no restriction on your x values. There is, however, a restriction on our range here. The restriction on our range is that this graph does not go above this y value. What is this y value? This y value is 1. Your graph, since it does not go above that, we're going to say y is an element of all real numbers such that y is less than or equal to 1. That just means that our graph is below 1 forever, okay? Now we're going to look at our reciprocal function. This, oh my gosh, I hate when this happens. This minus 2 here is a shift right by 2, okay? What does your reciprocal function look like? Your reciprocal function typically looks like this, but in this case, it's been shifted right by 2, so we have a vertical asymptote here at 2, and my graph now looks like this, okay? And so my domain on this graph is that, so we'll write my domain is x is an element of all real numbers. There is a restriction such that x cannot equal 2. Notice that this graph is never going to touch that line, which is where x equals to 2. So that's our restriction on our domain, and our range is going to be y is an element of all real numbers such that y, well, what's y never going to be? Y never touches your x-axis. So y is never going to be equal to 0. Okay? So that's our reciprocal function. And lastly here, our square root function. We know that our square root function, or hopefully we know that our square root function typically looks like this. Okay? This negative, that's a negative k value. That's a reflection in y-axis. And this 1 here, this plus 1, is a shift left 1 unit. So that graph actually is not going to look like what I have there. It's going to look something like this. Well, I'm going to draw that a little better for you. Kind of like that. So my domain of this function is x is an element of all real numbers such that, well, whoops, I gotta get my writing right here. Such that x is less than or equal to -1. Okay, this is the point that it starts at, is -1. And, I'm sorry, my range is going to be that y is an element of all real numbers such that y is greater than or equal to 0. Right, the y coordinate here is 0 and it's always above 0. All right, we've got a couple more questions left here. Determine the equation of the quadratic with x-intercepts at 2 and -2 and a y-intercept of 6. So you might remember from last year that y equals a x minus r and x minus s is the equation of a quadratic, or the general equation of a quadratic in factored form, okay, where r and s are my x-intercepts, okay? So what I'm going to do here is I'm going to write that in here. I'm going to just simplify this. I'm going to write y equals, one of my x-intercepts is 2, so I'm going to put in -2. My other x-intercept is -2, so x minus -2. Put those two pieces of information in. So I get y equals a, I'm going to just remove the brackets, so that's x minus 2, x plus 2. Okay. Now again, we're trying to determine the equation of this parabola. So I need to figure out what this a value is. Once I know what that a value is, I have the equation of this parabola. Okay, now how am I going to do that, right? We've used those two pieces of information. We have not used this piece of information, the y-intercept. And so the y-intercept is actually a point. That's the point 0, -6. And so this is an x-coordinate and a y-coordinate. And so what I'm going to do is I'm actually going to sub those in for x and y in my equation. So I'm going to sub those in. And what I do when I get that, what that looks like is I get -6 equals a We're going to go, what is I'm subbing in 0. 0 minus 2, 0 plus 2. That's negative 6 equals A. That's negative 2 times 2. That's negative 6 equals negative 4A. Okay, and just solving for A, I get 6 over 4 equals A, or 3 over 2 equals A. And so if I'm writing out my final equation of this function, it's going to be y equals 3 over 2, bracket x plus 2, x minus 2. And that's my final answer for that function there. Okay? Oh boy. Determine the vertex. Determine the x-intercept domain range of the following function. Okay. So what we want to do here, this is a great question. Okay, we're good. I gotta go to bed. We are going to factor this to start, okay? So we have 2x squared plus 5x minus 3. I'm going to factor this. So I'm going to go two numbers that multiply to negative 6 and add to 5. It's going to be 2 and 3. It's going to be negative 2 plus negative 3. No, it's going to be 6 and 1. It's going to be 6 and negative 1. Okay, so we get 2x squared plus 6x minus 1x minus 3. I'm going to factor out 2x. I get x plus 3. I'm going to factor out negative 1. I get x plus 3. I get 2. My factors are x plus 3 and 2x minus 1. Okay, that's my factored form. All right, so my x-intercepts here are at negative 3 and 1 over 2 based on those brackets. So I'm going to plot those. So I get negative 3, which is right here, and 1/2, which is right here. Okay. What am I trying to think of here? My vertex. Okay, if I want to figure out my vertex, I'm going to find the halfway point between negative 3 and so we're going to find the x coordinate of the vertex. Now this is a tricky question. Okay, this is making sure, just as checking everything that you know about kind of grade 10. This is grade 10 stuff, but a lot of grade 10 stuff, but also your algebra as well. So the x coordinate of the vertex, what we're going to do there is we're going to add my x-intercepts together, negative 3 plus 1/2, and then we're going to divide that by 2. So when I do that, negative 3 plus 1/2 is, that's 5 over, it's negative 5 over 2, all divided by 2, which is equal to negative 5 over 4. So that's right about, that's negative 1/4, which is right about here. So my vertex falls on that vertical line there. Okay? Oh my gosh. If I want to find the exact y value of the vertex, what I'm going to do is I'm going to take negative 5/4 and I'm going to sub that into my original function to find the y coordinate of the vertex. So I'm going to sub in f of negative 5 over 4. And when I do that, I get 2 bracket 5, negative 5 over 4 squared plus 5 bracket 5 over, negative 5 over 4 minus 3. I get, that's, oh boy. That is square 25. That's 50 over 16 plus, minus 25 over 4 minus 3. Oh boy, we're checking my mental math here. Times 4, that's negative 150 over 16. 3248 minus 48 over 16 equals, oh boy. I need my calculator. That's negative 198. Negative 198 over 16. And I don't know what that is. Negative 198 divided by 16 is negative 12.3. So negative 12. It's about negative 12.375, which is off of our graph. That vertex is down here somewhere. That's roughly what my graph looks like. Okay. The domain of that function is going to be all real numbers. The domain is going to be x is an element of all real numbers with all parabolas. That's always your domain. And my range is going to be y is an element of all real numbers such that y is greater than or equal to negative 12.375. Okay, that one's a little messy. That is a challenging question. But again, these are prerequisite skills. These are things that you are required to or would have done coming into this course. Okay. Last thing here, state the transformations. Okay. First one, this is a reflection over x-axis and a vertical stretch by factor of 3. Okay. My next one is a horizontal horizontal compression by a factor of baffle, you could say, you can use that for short, by a factor of 1/2, and a vertical, oh, I'm getting messy, it's getting late, vertical shift, down 7 units. Okay, this one here, horizontal flip, or you could say reflection in y-axis, and this one here is a vertical compression baffle by a factor of 1/2, and a horizontal shift right, or sorry, no, wow, left 3 units. Okay. That summarizes or goes through all of that. I tried to go through that fast. I think I got through that as fast as I could. Hopefully some of that stuff sticks, or hopefully you remember some of that stuff. I will answer questions that you have about this stuff on Monday, but we do have a quiz on these skills on Tuesday. Okay, so look it over on the weekend. If you haven't watched this video a couple times, make sure you understand how to do this stuff. Okay, this page here, the homework, basically gets you to do all that stuff again. So this page reinforces these pages reinforce that stuff that we just did there. Okay, there's some answers down there for you as well, and that is all that I have for you today. Have a great day.